Okay, so on this question, we have a funny looking function, and they want us to take the derivative of it and plug in 8. And they say use logarithmic differentiation. That is a good plan, actually. The reason is because we can't really take this derivative without it. Why not? Well, because we have a rule when x is in the base only, you have like numbers like 2, or let's say like what is, here, I'll just write real quick. If you had like x to the fourth, you know what the rule is. The derivative, the derivative rule, you just bring down the 4 and lower the power by 1, no big deal. Now, what if it's the other way around? What if the x is up in the power? Well, I don't know if you remember that, that was more tricky. It's like e to the x, you just do nothing, but then it's not e, so you have the adjustment ln4, like that. So we have a rule when x is in the base only with numbers in the power. That's the easy one. We have a derivative rule when x is in the power only and the bases are numbers. The base is a number. But we don't have a rule when the base is letters and the power. You see the problem? We have a rule when only the powers is x or only the base is x, but not both. So because we don't have a rule for that, we're going to have to do logarithmic differentiation. What does that mean? Well, that means step one, take the ln of both sides. So I'm going to come in here and go ln of the left side. Whoops, that's such a good one. And ln of the right side. Okay. So, and then step two is do the log properties. This is why we do logs, because they have some nice properties. What are those properties? Well, property number one is that the log of x times y is the log of x plus the log of y. And step two is log of x over y is the log of x minus the log of y. And the third property of logs is log of x to a power. That power drops down to the front. So, okay. So here we go. Now the left side, there's nothing really going on there. There's no properties on the left side. It's just ln of f of x. No big deal. But on the right side, we're going to use the properties. Now you might think, let me be helpful. Well, let's do this. This is multiplied, right? This is multiplied. So that's property one. So that's going to become, I don't know, I meant to change the color there. Thought I did. Thought I hit it. That's going to be ln of 2 plus, well, one in there, ln of x to the ln x, like that. Good so far? Because those are times, right? Times becomes adding. That's what this rule, this log property number one says. You have two things multiplied. Those are two separate logs, right? Two things multiplied inside of one log. You make two separate logs added. Ln is just a type of log. So, right. And then this power right here can drop down. That's log property three. Powers drop down to the front. So that's a little weird looking, I know, but it's true. Ln of left side's just kind of watching at this point. Ln of 2 plus now this ln x drops down to the front, and then we have the other ln x. See what happened there? The power dropped down to the front, and then we said ln x. So we get two of those. You could say squared, or just leave it like it is. Whatever. I'm just gonna leave it like it is. All right. So that was step two. Now, whoops. And now on step three, you take the derivative of both sides. And in specific, and if you remember, we've done this a couple times, when you take the derivative of that left side, it's always going to do the same thing. Derivative, what's it going to do? What's the derivative of ln? It's 1 over the argument. But then since the inside is not a simple x, the chain rule tells us we got to go times the derivative of the inside. And the derivative of the inside derivative of f of x is f prime of x. And that's over 1, so then that goes to the top. So we just say, look, it's just f prime of x over f of x. So that's what we always do on the left side. We just say, okay, look, it's f prime of x over regular f of x. Okay. Now on the right side, that's the derivative. So I just did I just did the derivative on the left side. Now I'm going to do the derivative on the right side. What's derivative on the right side? What's derivative of ln 2? 0. Because that's just a number. There's no x there anywhere. It's just you can find ln 2 on your calculator. It's a number. So how much does it change? What's its rate of change? That number is fixed. It doesn't have a variable. It's not varying. Its rate of change is 0. Remember, any number alone, even a fancy number like ln2 or e or something that doesn't have an x, the derivative is 0. It's not changing. It doesn't have a variable. Plus, okay. Now, how are we going to do this part? Well, this is two functions multiplied. That's a product rule. You might say, shouldn't we make that squared? You could, and then you'd have a power rule. Um, do you like that better? I mean, we could do that. I don't know. I'm just gonna do the product rule. So the derivative of the first one, that's 1 over x, times the second one unchanged, plus the first one unchanged, which will be just ln x, times the derivative of the second one, which is again 1 over x. So what do we got here? We got f prime of x, we're getting close, over f of x equals this and this are the same thing twice. So we just say there's two of them, two what's? ln x's over x, right? There's one of these and one of these. That's like terms, big, fancy like terms. And the ln x's always go to the top because they're over 1. It's two of those, right? That's what we do. That's like terms. When you have two x patterns that are identical, you add the invisible ones in the front, there's two of them. Okay. Yeah, we would have got the same thing, by the way. If instead of this is bugging you, you could say, look, sir, I'm just going to make this ln of x like that, whole thing squared. Yeah, that's fine. And you get the same answer in the end. Derivative, what happened? The 2 would come down. You get that 2 in the front, subtract 1 from the power. And you think, yeah, but then it's just ln x. Yeah, but then the chain rule says times derivative of the inside, derivative of ln x, 1 over x. So you'd have ln times 1 over x, you'd have this. Same thing. Same. Isn't it great the way math always works out? As long as we're logical. Anyway, we're not done yet. We're almost done. F prime's not alone yet. We want F prime alone, right? We want F prime of 8, in fact. So how do we get F prime alone? What's the fourth step always in logarithmic differentiation? Multiply both sides by f of x, the denominator. So I'm going to come in here and go, so I'm going to do this one more time here. So f prime of x over f of x equals, I'm just going to make this 2 ln x over x. This is 2 over 1, right? Multiply both sides by f of x, over 1. So this will cancel out. And this side by f of x. And boom, we've got f prime of x alone, finally. And so that equals, now what is f of x? What do we mean by f of x? Well, the original function f of x, what was that? Right here. That's f of x. 2 times x to the ln x. 2 times x to the ln x times 2 ln x, a little scribbly, ln x over x. And, I don't like extra parentheses. You don't need these. Just go times. Whew, there's the derivative. Now, last thing they want us to plug in 8, huh? So let's plug in 8. So now you take your calculator and you plug in an 8 there, an 8 there, an 8 there, and an 8 there. And hit the buttons on your calculator and you've got it. There we go. There's the derivative by logarithmic differentiation.